So this will map to 1. So the mapping will go like that, right? So it will go like that. So if you got f of 1, it's going to be what? It's going to be 4. F of 2, these are the elements. So this is the domain, and this is the what? The range. Here. Because if you say, if you look at this one, assuming that if for example I have given you this, and then I say can you map, and then I put here, I put it 5. If I put it 5, that 5 is not, does not exist if you do it like whatever there. It doesn't exist at all. Right? Therefore, that is 5. If you cannot map it, it is not mapped. But the elements that are being mapped are -5, 1, 4, and what? And 7. If that is not mapped, if you find that that is not mapped, it's where now we are saying that that is for what? For domain. Yes. It was just to show you that element A tuna katika element ya ina hii. Already katika arrow kwa jambo ambalo jambo katika B say. If it has got A is 1, B is 2. The only issue is jambo la sana. But the most important example is this one, where an element within the domain has to map with an element to the range. That's why this is the input and that one is the what? Output. If this is a machine, these are the raw materials, and out of the raw materials, you are now changing them, you are transforming them. And when you are transforming here, this becomes a function. Have you seen that as an X? That becomes a function, and that function now, it goes into what is coming out of it. Is it okay? Yeah. So, what can I say? Yes? No, it's possible that it will be given a function to find, and it will be given this to find the other side. Or you will be given this to find the other side. So, you use now, stop using. Or if they give you this, and you are given this function, where are you going to substitute? Alright, let me just say that I can give you an example, right? Okay, that's what we're going to use. Okay, very good. I'm not glad you are not going to use. Yes. Alright, let me answer that one question. He says, if you are given this, how can you find that? Who can answer that? Yes, very good. How do you? If you are given this, how would it come? If you are given, assuming you are given 4, how do you get 1? You given that come. Can you do this? I'm raising this. Why? So therefore why you can 44. 4 asali kopa. Sifuna liweze I know. Here's the point. I understand what he's saying. Yeah, what he's saying is this. If you have 4, right? I'm saying another name for y is f of what? X. Which means the whole of this letter here is the same as y. Right? It means that y is 4, right? And this y is the same as f of what? X. So what you just say 4, because that is 4 is f of x here, which is the same as y, is equal to 3x plus what? 1. It's a so much simple equation. So you take this one, it goes there, it's going to be 4 minus 1 is equal to 3 what? X. The subtract there. 3 is equal to 3 what? X. What is x? X is 1. That's why we have here what? 1. We are learning. Maybe I will learn from you.
We had this when we were at secondary school. We used to do this. There.
Okay.
This is domain. Means equation. And range. We substitute. When we want to find out domain, we equate the thing.
Okay.
When we want to find range, we substitute.
Oh yeah. I think I've learned from him. I didn't even know. I've learned, but now I've known. The teacher that where he said, actually he wrote this or that is there, where domain you use equation. And the range, you use substitution. The way we have done here, you put the 4. If you put the 4 here, you are substituting. 4 is equal to 3x plus 1. If you want to 7, write 7 is equal to 3x plus 1. Negative 5. Negative 5 is equal to 3x plus. So you use that and you can find what will be there. So you substitute. We are substituting to get it the other side from this one. But if you want to use this one, you take that x and you substitute it there and you get the y. But from the other side, this one is the same as y. So y is the negative 5 is equal to 3x plus 1. You can find what it is. That's what it means. Right? Alright. Let's just proceed. Now I was telling this. Why do we involve ourselves in learning this in business mathematics? That's the issue. Because you have to know what the reason why you are learning domain and range in mathematics. Oh, yeah, can you answer that?
Alright, which why available range? Neither 1, 2, 3, 4. Where the one I show 4 sana mangine map. The wow XC. Then the question is, what if wow XC sana mangine map y? Let's say we call it A, B, C, D.
A, B, C, D. A, B, C, D. Sana mangine map to the other side.
Yes.
Zote.
Zina
yake ndio ulikuta. Ulizana wapi? Naka ndio kwani boss, nikuze unarudi kale zalo this minute. That's why I was saying that I think from there now is the problem. You see what? When I was giving you this example, I did not know that you think because what I'm doing is education. That's very nice. That's why I think it's very nice. When I was example, I didn't even know that others, you have got the idea of what is happening here. Which means I have the assumption that where you are coming from, you guys relate to this thing. Right? For example, yeah, right. You read about it. But the only thing that people have forgotten. That is your that you are. But over that day, you have to be and four boys going like that, right? You want to drink, right? Alright? And let's get this. Now, I would say, why do we bother learning this? Now, the issue is, I want to give you this example. This example is going to, I think I'll do the example. You see, why do we learn this one? This issue of learning domain and the functions to you in business is very, very important. How are we going now? Hey. Okay, fine. You are listening, right? Okay. Now, I'm saying, why is this important? What is important? Because when we are learning this, what will it help us in the future, right? Yes. When you look at these functions, there are other times, right? You may be required if you want to find profit, and whether you want to find profit or loss based on materials, right? 500 cartons, you are buying one carton at like 200 watts, then you multiply that, and if someone maybe 300 cartons, you buy them at price tag, then you get that. You can easily find profit or find loss if you want to using the function. I'm giving you an example here. Let me just give you this example. Right. Then what I will do is simple. My very simple. I'll just give you the comparison range. I can just give you range, find domain. And I can give you other domain. You continue with range. You should be able to know how to complete that, right? Range is 5, 4, 6 that you choose. Something you choose, right? Alright. An example. This is the example 5. I think we can clear around this example today. I think we proceed. So if I go with the example, that's the 5. Let me just do this example. You learned something about you learned something about linear programming. Where you have to find physical region, the shared region, right? You have to share it and where you have the solutions. You know about that? That's what I'm talking about here. We'll learn about that. There's a very good point from where I am. Don't miss that point. You can miss everything that I have said, but don't miss what I have written there. Example. Let's think of this function. Y is equal to 150 or 15,000. 15,000 plus 208. Which means it's the same as f of x. Because it's going to write it the same as f of x is equal to 15,000 plus 208. It's the same. Right? Such that the word y is the same as f of x. Right? So, when that is like this, it's the same as saying f of x is equal to this one. Right? But there is this point that I want you. What does that mean? What it means there is, what is if this is f of 2? If this is f of 2, you will change it. It means 200 times 2 here. Then you add this one. What if it is f of 0? It means it's going to be multiply this times z, right? This. What that's the meaning. So you can see that we are looking at it domain and range. Have you seen that one? If I say f of is the domain. The range is the answer you are getting when you substitute there. Do you remember? If we say, if it is f of 1, so if it is f of what? 1, it means you are substituting 15,000 plus 200 times 1. Yes? So 200 times 1 is 200, right? That 200 plus each equals 15,200, right? That one is your range. That one is your what? Range. Now, if that is your range, what will be your domain? Your domain will be what? 1. Your domain will be 1. Alright. Manamba haya ndio mpaka substitute yake. Pale x, right? Ndio manamba tu substitute ama chana majani. No substitute. We call them domain. Right? Domain is the number that we are substituting here. Range now, the answer I need to get is about substitute. Hey, what is answer? F of 1. 1 is domain. Hey, then I want to tell you that 1 times 2 part is a new. Answer to measure is that we have done range. Then we have this and map there. Yeah. If this is 0, f of 0, it means that is 0 what will be domain? Now the range is that you multiply this by 0, it was a 0, right? With 13. Uyu, ya vya sasa ujali range. So you could be there. Time range was one. So far, suppose this is the f of 1. So at f of 1, you will be 1. Yes. Now the one you go up map in function. Function actually, right? Is the f of x, right? The function has to be 15,000 plus 200x, right? You jump you jump range, right? You know what does that mean? Mugani one you times up x, x because we use the x. This one is x and this is what? Y. Then we substitute. We later one and then 200 times 1 is 200 here, right? And that 200 plus 15,000 is going to be 15,200. Because of this or negative. You can substitute using negative numbers, right? It is possible. Assuming that it is negative 20, you will find that you can put negative 20 there. Negative 10, provided you know how to substitute it, you are substituting. You are putting in place. What about if it is 0? What about if it is 1? Is that the first time? You know them must go back substitute to pay the answer. Right? This is what time we never put it 20. They will go to 20 exams and because this is x. X is negative 20. Negative 20 times this one, you have to add this. That's what it means. God come and answer here. Hey, what you are getting from there to there is being different, right? Then I was saying, this is our function. But I'm not talking about this function. What I'm talking about here is this statement here. This statement is very important. Yeah, that one is very important. I'm saying, in this example, x represents number of units of goods sold by the salesman. X. Assuming we are going to 20. Right? Allow to 20. Using this, you can find out what is the y. And the y is the monthly pay that this guy is going to get. Why he presents market effect? This is what I have based on the market. Right? Market has been to trade. They would pay and based on the market. So in this situation, it's the same as an agent. You know one agent, eh? More faster by units. Well, put the units market. Ula jangama za market. Eh? They will pass the equation. Assuming you have put the unit was, they will have 200 times 1, then plus that one. That is the monthly salary you are going to give. Assuming this guy has sold 100 units, they move plus 100 times this one plus this one, that is the monthly pay. It means you will give the person based on what he has, what he has done, right?
Yes.
Based on the work he has done.
Yes.
Start a village, they will zero. Start a village to submit. Was that 1% damage? 2%, 15,000. Chipati na village. That will be a 15,000. Chipati will buy zero. Go and die, what such a mode. They will put everything more bullies. What is that one times Paris? That one percent is we. What is that 200 times that Paris and that? No salary. They will just have one to put it on me, put it on the Ramazan. That's exactly what happened here. Then, in this example 8, if you represent, I think I will give you the say. There you go. What I'm trying to say. What it means here is the amount of money you are going to receive. It depends on how many products have you sold. Right? That is happening in business. That's why this is called business mathematics. And that is the reason why I was saying you learned about this linear programming. Linear programming, you had to come up with a drawing. We have now put the same as you are. Linear programming, what was happening is something like this. Linear programming, you are coming something like this. You are coming up with a drawing like that. Right? That is a line. You are looking at a line, this is a line, and you are coming up with another line coming from this, and they were saying, where is your solution? Where do you think that you are making profit? You know what I mean? And then we say that profit, they will show that our profit, they will have 46 points. And we are shooting based on that. You know that? Because I have forgotten, I read that one in the 1980s. That's why maybe I cannot remember, but I know it was something like that. If we choose that, this one, and we are taking that, substituting it here, and finding out what is there. If this is the line, and this line it has got its own equation, this is the line has got its own equation, you are calculating what is there, and what is there. And you have this way, they say maximum, minimum, I don't know. Hey? So you are saying, profit, it was here. And then they say, sharing a region of one physical region, right? So you are able to share it. And one day region, something like you said, something like that. I think that's the process. Yes, right. Then I'm talking about this. Who say, different marriages, you have to understand here. Understand what is happening here. Right? will depend on the number of goods you are going to sell. If you have sold many goods, the salary will increase. If you sell little goods, the salary will go down. Right? You see that there is that connection.
Yes.
So Y is called dependent what? Variable. Why is dependent variable? It is a dependent variable the Y because Y depends on the number of goods you are going to what? To sell. It's a dependent variable simply because this one, the Y depends on X. While the Y itself, while the X is independent variable. The X is being independent variable because this is a standalone variable. Variable that does not change at all. It's not changing. What is changing? The O. X that I told you. But what is changing is Y. Therefore, Y is what is called dependent what? Variable. Therefore, if you have to draw a graph, it's going to be something like this. This is what is called dependent what? Variable. And this one is independent what? Variable. You see how far is it? Like this? I know. Alipoenda kuko mtekela shibani kama mzatekela kama katika form EF4. Because if you are going to use the very same things here in your research, they will ask you, can you define what is the dependent variable? Can you define from your research? Can you point out which are dependent variable and which are your independent variable? So you have to find out why do we call that dependent variable? Why do we call that independent variable? So dependent variable, the Y will depend on X. X does not change. X remains to be like that. But what is changing is the Y. Therefore, Y is the dependent variable. X is independent. I'm not going to buy X. But what is changing? X will be the number of boxes that I was telling here. But what is changing is the Y. Your salary is the one that is changing. Well, with some box 200, so you use this one. What will be changing there is this one. And what is changing? That is the dependent variable. What is not changing? That is the independent what? Therefore, the X is the independent variable, and then the Y is dependent what? Variable. As soon as I think you are going to understand it with other lecturer when they are talking about dependent and independent. They will be talking about these things there for long. Yes?
However, 2000 example.
Which one?
For instance, Master say the already FX in the salary. Name of France is 15,000.
15,000. Oh, a million. Okay, you can come up with an equation. It's not that a million else. You can use your own equation. For example, let me say something like this. You must say George, will be constant. I will be a constant. The kind of police, come around and by that. That's the constant. Because it's a constant. Suppose something like this. We have to consider this one. Y is equal to 3x plus y. Hey, we have to just, and this is the equation of the line. I understand that, I think. If you have a straight line like that, right? Yes. Just also don't you why one you are doing that? What does it mean? If it is on the graph, this is where the graph is cutting the y what? You remember about that one? And this one is your gradient. Hey? Gradient is where it is slanting. Is it slanting into the other side or the other side? Now, according to your question, you are saying, what do you have with me, this is just constant. Assuming, you use zero. Zero y is equal to what? 1. 1 is still going to be a constant. It's not changing at all. But what is changing? If you put x to be 1, when you put x to be if x is 1, assuming that x is equal to 1, here is going to be what? 3 times 1? 3 plus 1. So y is equal to what? 4. What does that mean? If you are to draw mapping, you have to draw mapping like this. My function is f of x is equal to 3x plus what? 1. Therefore, so now when I'm talking about mapping, this is when I'm y. I'm talking about a function of x. Therefore, that's only my because that we can draw that and you tell me that this is y. I'm not talking about this to be y. I'm saying that this is a function of what? X is defined to be 3x plus what? 1. This must have very strict to me. Then, if that is the case, 1 is here. And this 1 is mapping with what? Oh, 4. Like that one. Now, if you look at that one, what is changing? The one that is changing is this is the y. Right? And this one is what? X. Therefore, whatever you put there, every number you put in my x, because my x was my x is a number from negative 0, 1, 2, 3, 4, 8. I'm not about to die. But I'm not going to die. You use the numbers from the real line. Somebody have a number from negative 3, negative 2, negative 1, 0, 1, 2, 3. See much? Huh? And then also do this. Why? Which one is what has been? Is smart here. This is not such a way. Can you do what America? I have special marriages for why? Sure, yes? Now what is changing there is what? Why? The fact that why is changing, that why is more dependent on because it is the one that is changing. Why is this? This is not how it is. This is found out the little line. You know what a little line? You know a number line? This is a number. Then because they don't change, we call that one as now independent journey. What is this? Someone in Europe will have to have that. Because when we change, that's and why. Therefore, that why is what is called dependent what? And a very good example is this one. I know you don't have kids, but assuming that you have kids. Oh, you are right. Oh, that's nice. Oh, that's good. I like that. You know, it's rare to disclose. And then when it's in one, but it's cool to say I have got kids, 2 kids. This is the man I am. Alright, now, what I'm saying is, an example is, for a baby to grow, growth of a baby, I'm a funa Mana kuda akula mafuna jani. Jakulia, mana kuda kaiwa nzemu, ama funa jani. Mana kuda kaiwa nzemu, environment kali yabu ino, kuli yabu ino, ukale zonyiba kuna TV azonera, makatuzi, ama kala nzewe. Makolo tumzikondana, mana kala wajani? What does that mean? How does that there is independent variable and there is independent what? If you look at that one, what is making this baby to grow? Those are variables. Right? Those are variables. What are making this baby to grow? They are variables. But now, for you to see the change, they want to change it. Right? Right? They depend variable independent. I'm talking about the intelligence. Let me just do it again. We have here intelligence. Intelligence versus here we have got this factor here. 4 here we know. Another one? Environment, lab, environment. Okay, alright, okay. entertainment. What else? Entertainment. Commando. Banyak orang ula ulimonda like fish. Like fish. Don't fight mama ama ya kuona ana kujiburani. Ama onelea mambo yetu chini chizani siku. Now, if you look at this one, what is change? Assuming mana ibu mana japulia. What will change? The intelligence will change, right? So the behavior will change. If love, I guess this one will be affected, right? Which one is your X and which one is your Y? Yeah? Out of this, which one is your X and which one is Y? Huh? This one is what? This one is X and this one is what? Y. Why is it that this is Y? These are the factors that you are giving this one to change. Are you saying that this X and this is what? And this is what? Y. And this is what? X. Because for the change to happen, it depends on what? So therefore this is what else variable is this one? Dependent variable. And this one is independent what? Independent variable. And this one is independent what? Yeah, any question? Yes? Yeah, what? No. Not one of the reasons why we are learning the function. We are learning the function so that you have to find out in business, for something to happen, there must be other factors that you have to take for the business. Kuna factors that you have to take variables, X and what? And Y. For example, if you want your business to do very well, you need to have more capital, right? You need to have management, right? For management capital, whatever the central resources is to affect the production. But when the production of the car, you see what? That's why we have got dependent variable and independent what? That's how we are learning about function. What's the name now?
Well,